So on this page, we start to see some logs. So I have log base b of 1 over b cubed. So we remember that a logarithm asks us what exponent for the base gives me that number. So what exponent for b gives me 1 over b cubed? That would be a -3 exponent, right? Because we know b to the -3rd equals 1 over b cubed. So that would be choice 4. Looking at the next one, this is kind of an odd question. I'm going to try here writing 16 as a power of 2. That's 2 to the 4th. So then I see that I could subtract those exponents. So that would be choice 1. The next one, it says, what values of x are not in the domain of the function? So I suggest graphing this one on your calculator and just looking at your table and seeing which values don't work. If you did that, you would see that for 2, there's an error, there's no value. The reason being, we can't take logs of negatives, so 2x minus 8, we also can't take a log of 0, has to be greater than 0. When I solve this equation, I get that x is only numbers that are greater than 4. And if I graphed this equation, if you look at the graph, we call that a vertical asymptote, and that's at 4. And the graph would show up somewhere over here, moved a little bit, as I said, because of, there's some transformations going on here, but that's the idea. No x values smaller than 4 or 4 itself. The next one says which equation is graphed on the grid below. So first off, I would just graph all 4 of them. It becomes very obvious that neither of the exponential equations are correct, and it also, we can see, does not have an exponential shape. It has a logarithmic shape. Now to start to get to the nitty-gritty of which one of these equations is correct, I see this vertical asymptote at 2. Now I know for choice 3, this means my basic log graph that should have a vertical asymptote at x equals 0 has been shifted to the right 2. So this is the correct one. Also, if I graphed into my calculator, I could see that this one would have a vertical asymptote at x equals -2 because it was shifted left 2. So the next equation we're asking, where is the function equal to 90? Okay, so if this is f of x, which of the following values of x solves the equation f of x equals 90? I'm going to solve this algebraically. There's no reason, since it's multiple choice, you couldn't solve it with a graph, but just to go over that process, we'll do that. So I want to isolate the exponential part. So the first thing we're going to do is subtract 75. And we get 15 equals 50 times 0.92 to the x. We're going to divide by 50, and then we're going to get 0.92 to the x equals 0.3. Now this is not something where I can make the bases the same, but I do have that bend form. So I'm going to write that down now. I have a base, an exponent, and a number, and we're going to put it into log base number equals exponent form or log Benny. So when I write this down, I have log, my base is 0.92, my number, right, which is in this location and needs to go here, is 0.3, and that equals x. So we're going to type this in our calculator, okay, and see what we get. You'll definitely need probably a graphing calculator. There's some online that you can search for. There's one called Rapid Tables to type in the logs with bases other than 10 or e. But you would get 14.4 for that. So this answer is 2. I don't really have room to write it, but that is the answer. So the last one, we have to take an expression and change it into this form. So let's just start simplifying first to see what we can get. So I'm going to multiply the exponents in the numerator. That gives me a -6. In the denominator, I get x to the 7th because we're adding, because we're multiplying, adding the exponents because we're multiplying. Now they want me to move everything to the denominator, which is what I would do anyway, because I see a negative exponent, so we know that means division.